Factoring seems to be a topic in algebra class that gives a lot of students a lot of problems. Maybe you had a really bad teacher, or maybe you just plain didn't understand it when it was covered, and then boom, you're on to something new. Well, I've put together 10 examples here to give you hopefully a solid foundation of understanding for factoring, all the different types of factoring that you could encounter. So I hope you'll watch and participate through these 10 examples. Maybe get some paper out, you try it before I do, and see if you can figure out how I'm factoring, because there are different types of factoring, and that's the important thing to understand. Now, what does it mean to factor? To factor, it simply means to split a number up into, maybe it's prime factors. They don't have to be prime, but in this example they are. It means they can't split anymore. So 10 is the same thing as 5 times 2. That's what it means to factor. So when the directions say factor, you're actually dividing. You're dividing it up. So one type of factoring is what we call the greatest common factor. And as you can see here, we've got two terms, and both of the terms are divisible by something. You see, first of all, they're both even numbers, so certainly they're both divisible by 2. Can you go any higher? What goes into 12 and 20? I almost said it there. Yeah, 4. 4 goes into both of those, and what else do they both have? These two terms that are separated by subtraction both have the factor x hiding in it. So we can factor out the greatest common factor. So we're going to do the distributive property in reverse is one way to think about this. So out front here, we're going to write the greatest common factor. So we said they're both divisible by 4, and they're both divisible by x. Now, what goes in here? Well, 4x times what would give us the 12x squared? So we're doing the distributive property in reverse. So 4 times what is 12? 3. X times what is x squared? X. And then in the second spot, what would have to go here to make our negative 20x? Well, I already put the minus sign in there. 4x times 5. So you can always grade your paper, you can always grade your problem by doing the distributive property and just seeing if you get the original problem back. And lo and behold, we do. So we have just split this original polynomial into 1, 2, 3 factors. These are called factors. Okay, and we can't go any further on that because these are all prime at this point. As you learn, as you get more experience, 3x minus 5 is unfactorable, so we are done. All right, moving on to number 2. This is a different type of factoring. As you look at it, is there a greatest common factor? There's 3 terms. Does anything divide into all of them? No. So since we see an x squared here, that's our clue that maybe we need to try the good old-fashioned reverse FOIL technique here. Now, hopefully you remembered how to FOIL. I'll kind of go through that as I'm showing you how to factor this. So it has to be x and x, because in FOIL, these first 2 terms, that's what F stands for in FOIL, have to multiply to be x squared. So it has to be x and x. All right, now the signs both have to be pluses. That's the only way this is going to work, because after all, we have 2 pluses here. All right, so these both have to be pluses. I have an example here next where we've got some minuses, and I'll talk about that here in a second. At the next point, right here, this is the L in FOIL. It's where you multiply those 2 things to give 12. So what multiplies to be 12? Let's write it over here. 6 times 2, 4 times 3, and 12 times 1. Which of those adds up to 7? The 4 and the 3 add up to 7, and the 7 came from right here. So it's x plus 3, x plus 4. This polynomial, this is called a 3-term polynomial, has 2 factors, x plus 3 and x plus 4. So far you've learned how to take the greatest common factor out if there is one. There isn't always, right? That's not always the case. But if there is one, you want to do that. You want to take the greatest common factor out. If there is no greatest common factor, then go ahead and look and see, do you have an x squared term? Can you factor this? And indeed, it did reverse FOIL, is one type of factoring. So let's do another reverse FOIL question, this time with some negatives in here, and see how this works out. I think of this like a number riddle. It's got to be x and x. The only way you're going to make negative 18 by multiplication is by taking a positive times a negative, right, to make that negative. That's the only way it's going to work. So I always like to fill in what I know has to be true, and that helps me solve the problem eventually. All right, so now let's think about what multiplies to be 18. 18 and 1, 6 and 3, 9 and 2. Do any of those add up to 3? Well, no, right? But don't forget, we're going to make one of them negative because we want a negative last term. So one of them has to be negative, and if we make the bigger number negative, it will cause the middle term to be negative. You see how negative 6 plus 3 will make that middle term. So we put the 6 here and the 3 here. Now, I guess I didn't fully explain on the last example about where the O and the I in FOIL come from. It's the outside right here and the inside right here. So this is 3x, and then on the outside, it's negative 6x. And you see that those add up to be this term right here. That's what needs to be true. So it's FOIL. FOIL. And I have a really good video about the FOIL method, so I'll try to link to it in the comments and up above. All right, so let's move on to number 4. We're making good progress here with different types of factoring. So just stick with this. We're going to get to some mixed problems here in a bit. X squared minus 9. Now, there's no greatest common factor because like this doesn't have a 3 in it, for example. This is only divisible by x and 1. This is only divisible by 9, 1, and 3. So there is no greatest common factor. However, this is one of those special ones where we have a difference, that means subtraction, of 2 perfect squares. And these factor into a really kind of neat pattern, x plus 3 and x minus 3. So it actually reverse FOILs into this. Let's see how this works. X times x makes x squared. And then the O and the I, what do those add up to be when you multiply them out? 3x and negative 3x add up to 0x. That's why there's no middle term here, because it's 0x. It's just hidden there. And then the last part, 3 times negative 3 gives us the negative 9 that you see here. So a difference of 2 perfect squares will factor into what we call a sum and difference pattern, addition and subtraction. And it's a pretty cool little pattern, and it's a good one to spot. And I've got another one of these lined up here, believe it or not. This one looks a little crazier, right? Number 5 here. But do you see that we have 2 terms? There's subtraction. The first one is an x squared term, and the number 4 is a perfect square. 2 squared is 4. And the number 25 is a perfect square. It's 5 times 5, or 5 squared. So this factors into 2x plus 5, 2x minus 5. So I've been using the word factoring a lot. There's all different kinds of factoring. These are some special cases here. We did 2 reverse FOIL examples, and then we also split it up. Remember, that's what factoring is, right? Splitting it up. We split it up with the greatest common factor. All right, now we're going to start mixing it all together, folks. And this is where it gets kind of interesting, and maybe where you need a little bit of extra practice. So I've got some good problems here lined up. This problem has 3 terms. Are there any numbers that divide into all of them? Any number that divides into 3, 18, and 15? 3. They're all divisible by 3. Now, some students make the mistake of thinking that we're going to divide everything by 3 and just get rid of it, but that's not the case. All right, we're going to divide it out. which means it's going to end up out front. So the first step is greatest common factor. And what's left behind when you divide 3 out of this? Or you could say 3 times what, right here, makes 3x squared. It's got to be x squared. You knew that. So we'll put our x squared in here. The next term would be 3 times what is 18x? And of course the answer is 6x. And then the last term here is 5. Now you might be excited to go on to the next problem. You're like, oh yeah, I got that. That was pretty easy. Well, look at this. This is called a trinomial. It's got 3 terms. It's got an x squared in it. And we gotta check that maybe, just maybe, it's something like these guys here where we can reverse FOIL them. So we're going to try and see. Sometimes it doesn't. Sometimes we're done. But we got to try. So x times x multiplies to be x squared. All right, what multiplies to be 5 but adds up to be 6? Well, that's easy. 5 and 1. Look at that. So this original polynomial, 3x squared plus 18x plus 15, split into 3 factors. The number 3, x plus 5, and x plus 1. So those are called factors, and there were 3 of them hiding in there in that original problem. Number 7, oh my goodness, x to the 4th. What are we going to do with that? Well, if you look over here, there's an x squared, so that's helpful. And I see both of these are divisible by 5. You could try to think of a bigger number, but I think 5 is the biggest. So we can start with the greatest common factor. Always look for the greatest common factor first. I say that all the time to my students, and they seem to forget about it. So hopefully you'll remember after these 10 examples. So we're going to factor out a 5. We're going to factor out an x squared also, because they all have it. And that leaves behind what on the inside? 5x squared times what would give us this first term? What would go in here? 4x squared minus, and then 9. Well, my goodness, this looks a bit similar to this last question. This is a difference of squares, so we can go and split this up yet again. 2x plus 3, 2x minus 3. That was called a difference of perfect squares. So it factors into this pattern, 2x plus 3, 2x minus 3. And we did one like that a couple ago, right? 4x squared minus 25. That was very similar. 9 is also a perfect square, which is what this problem had in it. All right, so that was great. Now you might think, oh, I know everything. Uh-oh. Number 8's a little different, and I've got a couple videos on this, and one of them is actually my most popular video. It has to do with how to factor polynomials where you have a number in the front, ax squared. And there's no GCF this time. There's no GCF. So what are we going to do? There's a very cool algorithm, very cool way to do this. We could guess and check, and honestly, I'm good enough at this that that's the way I do it, is I would guess and check this one. I've got a different example lined up next that's a little bit more difficult, and I would have troubles guessing and checking. So let me show you the algorithm. It's really cool. I remember when a fellow teacher showed me this, and I thought, wow, I gotta start teaching. This is really cool. What you do is you take the number in the front and the number at the end. That's the A and the C, and we multiply them. So 2 times negative 15 equals negative 30. And we write it off to the side. And now we take the number negative 30 and we split it up in multiple different ways. So, for example, negative 30, or let's do positive 30 and negative 1, right? Those multiply to be negative 30. What other ways? Let's see. 6 and negative 5. What about, let's see, 10 and negative 3. And we're looking for something that will add up to be the middle term. So out of those four, do you see, look at this. This combination right here adds up to be 7x. So if this polynomial is factorable, that's a big if, capital I, capital F. If it's factorable, then you'll find a hit somewhere in here, and we did. So watch what I do. I'm going to rewrite the problem by just taking this 7x and rewriting it as 10x minus 3x. It's basically unsimplifying it, right? Reverse simplifying here. Plus. Now we do what's called the grouping method. The grouping method. The grouping method, I have a video on this as well because it's a popular method and also often gives students some confusion. Is you group the first two together and you look at those exclusively. So those have a greatest common factor of 2x, and that leaves behind x plus 5. Let me show you here. Those two have their own greatest common factor. And then the final two, I'm going to factor a negative 3 out of those. And then I get an x plus 5 left behind. What do you notice? Do you see something here? Something jumping out at you? Do you see that the x plus 5 here is the same binomial that we see in the second one? They have a common binomial, it's called. So we factor that out, right? Whenever a polynomial has a common factor like this, we factor it out and we write it out front. So I'm writing it one time out front, and then I write what's left behind, which was the 2x that was red and the green negative 3. Let me highlight this for you. So right here, this 2x was left behind and this negative 3 was left behind. We just reverse foiled that original problem and there wasn't any guessing and checking. Here's the answer, and you could check your answer, of course, by doing the FOIL method. So let's do that really quickly. What's x times 2x? 2x squared. What's 10 minus 3x? 7x. And then what is 5 times minus 3? Negative 15. Look at that. We just reverse foiled using an algorithm off to the side here. And I've got another example queued up on this because I know that this is challenging, and I will certainly link to my video, my popular video on this method. The first step is to take these first and last numbers, 21 and negative 2, and multiply them. So I'm going to write that off to the side, negative 42. Now we're going to split up negative 42, and I'm going to make the bigger number the negative because I want my middle term to be negative. So I'm just going to go ahead and do that. Let's see, this would be, what would it be? Is it negative 7 and 6? Well, no. Okay, I think I got it. How about negative 14 and 3? 14 times 3 is 42. So you see how that adds up to be the negative 11, that middle term. So I'm going to rewrite that middle term as negative 14x plus 3x. I'm going to bring down the minus 2 here. I'm going to bring down the 21x squared. I now do the greatest common factor on the first two, which is 7 and x, and that leaves behind 3x minus 2. Now on the second one, boy, I'm glad this worked out this way. This is a good one to talk about. You see how this already matches this here? So we have to pull out a 1. We're going to put a placeholder there of a 1. That way we can follow the rest of our algorithm and write the common binomial in the front like I did on the last one, and then write what's left behind, which is 7x plus 1. So there's our factorization of that original trinomial, which was actually pretty scary, but I just followed this algorithm and I found my hit, and that allowed me to then do what's called the grouping method, where you group the first two together, you group the last two together, and then in the end, hopefully, if you have a common binomial, then it must have been factorable and you can go ahead and factor it. Okay, one more example. Stick with me here. There must be something good here. All right, number 10 here. You might think, hey, let's just jump in and start doing the algorithm, right? Let's take our 22 times our negative 2. But before you do that, always check for a GCF first. Always, folks. Because your life may get a lot easier if you check for a GCF first. And indeed, they're all divisible by 2. And I think it would be wise to go ahead and factor out the minus sign. That's one thing I wanted to comment here, is that sometimes taking out a minus sign is the intelligent thing to do because it will make your life so much easier, and you want these problems to be easy, don't you? Plus 10x, and then minus 11. All right, so negative 2, and now we just do our reverse FOIL. It's got to be x and x. It's got to be a plus and a minus because that's the only way you're going to multiply and get a negative. Now, what two numbers here and here will then add up to be that 10? Now, they have to make negative 11, and of course, you're probably screaming at your computer here that it's 11 and negative 1. You see how that foils out then to be x squared plus 10x minus 11. And look at that. We're done. These are prime. So this original polynomial splits into 3 factors here. So these are all called factors. All right, well, hopefully this was helpful for you, and I will certainly link to my other factoring videos. I have a lot of them because a lot of students need a lot of practice on factoring. So hopefully this was useful to you, and good luck on your assignments. Okay, until next time.